Hello, my name's Matthew Tinkler. I'm a maths teacher from Newport. I've been teaching additional maths for roughly 10 to 12 years. And for the next 3 sessions, I'll be talking about completing the square, factorising quadratics, which again supports GCSE maths, slightly higher order, and then factor and remainder theorem that builds on session 6. If you're wondering where session 1, 2, 3, and 4 are, they were completed last year and also on the e-sgol recording site on the additional maths. The additional maths comes under the GCSE folder of questions. It's a level 2, but that's where you'll find them. So today's session, completing the square. Now you might have done this for GCSE maths anyway. I sometimes teach it, well I do teach it for GCSE maths because it's fairly short and sharp, but I use my additional maths questions to build it up. So completing the square is another method used to solve quadratic equations, and it helps you with minimums and maximums. One of my previous presentations was about using d2y dx squared to prove if a curve where it is the minimum point and the maximum point. This is just a different way to do it. So to complete the square, we need to be in this form. So although it says x plus or minus, obviously, and it says plus or minus, we'll just use one of them. If I was you, I'd write that down to get you going, but we'll see half a dozen questions coming up soon to give you a practice. So here's the first example. Now, completing the square means, let's just show you this, we need to be in the format of something with a squared and then with a term on the end, a constant term on the end. So first of all, we've done x plus 3 all squared. Now I'll show you on the next slide where the plus 3 comes from, but I would be teaching and asking, where do you think the 3 has come from? 3 has come from half of 6. So I've halved the x coefficient. You can see the x coefficient is worth 6, half of 6 is 3. Then the next bit is minus 9. Now where's that come from? We subtract the square of the number to counteract the plus 3 being squared. What I mean by that is, if I foiled this out or box gridded it out or multiplied out the double brackets, I would end up with x squared plus 6x plus 9, because 3 squared is plus 9, but I don't want a plus 9. So I take away the 9 straight away. So I've done 3 squared is 9, take away 9 to counteract, it disappears, leaving me a plus 10. When I was in school, we were taught straight away to just do, well, that's 9, so that's plus 10. We were told just to write plus 1 on the end. But I think for teaching now, I think it's a lot easier for everyone to see where all these steps have come from. Then we add, subtract the constant. So if that said plus 73, I would have plus 73 there. And the next line's pretty straightforward. Minus 9 plus 10 just gives us plus 1 to simplify it. And that's what we mean by completing the square. Now, when I go on to some past paper questions, there's a bit more to it than this. But here's the next example, and my keynote by the side should help you. So what I would suggest you do is just stop the video for 30 seconds or a minute and just see what you can come up with yourself. I know it's quite a lot to expect you after one example. You can go back and have a look at the example. Otherwise, it will then drift on and I will go through my solution. So I'll give you a minute to see if you can do example 2. Okay, so this example 2 is a slight difference because it says minus 8x in the middle, but still a half of minus 8 is minus 4. Now, you might think, why does it say minus 16 here? Well, if you do minus 4 squared, minus 4 times minus 4 is plus 16. From the squaring of the brackets, you're always going to end up with a plus constant term. So you'll always put a minus straight away after. Whether it says a plus in the middle or a minus in the middle, you'll always have a minus straight away. Because minus 4 squared is plus 16, so to counteract it, I do minus 16. And then the next line is pretty straightforward. So again, I'll give you 30 odd seconds to see if you would like to try example 3 yourself. It's a bit of a mixture of example 1 and example 2. Okay, so half of 12 is 6. Now, the type of thing when I mark these questions, you'll often see people forget to put the squared on the end. Don't ask me why, they just do. And if they forget to do the squared, they've dropped all the marks. So that's a method mark for getting this bracket correct with the squared on. Again, plus 6, whether it's -4 or plus 6, doesn't matter. There's always a minus straight away after follows the bracket, because 6 squared is 36. So you minus 36 to counteract that, and then that still says minus 38. Now, it is a calculated exam, so it's up to you how to do minus 36, minus 38, and the answers come out at the bottom, and I know it's on covered by the border, but minus 36, minus 38 is another minus 74. This topic is also taught at A level as well. Okay, so sketching the graphs. Now, so far on all the additional maths papers, and they've been going since, I think, 2011, I think the papers go back to, before there was a slightly different additional maths course. They've not asked us to draw a graph of anything yet, but I've just put this slide in to show you, and again, you will do this at A level. So here's your first example link to this. We're going to complete the square. Half of 10 is 5. 5 squared is 5 squared is 25, so minus 25 to counteract that. It ends up as x plus 5 squared minus 28. So how does this relate to a sketch? Well, it's a quadratic curve, and it's also a positive quadratic curve, so it would go down and then up, making what I would call a smiley face. When it's a minus x squared, it would make a grumpy face, a negative face, but it's a positive parabola. So we've got a is 5 and b is minus 28. When x is minus 5, and we will talk about this more when I get to the past paper questions, but when x is minus 5, that's the lowest answer we can get, because minus 5 plus 5 is 0. 0 squared is 0. 0 take away 28 is minus 28. That's the lowest the graph can get to. If you don't believe me, if you want to put in minus 100, minus 100 plus 5 is minus 95. If you do minus 95 squared, it's going to come out as a positive answer. So this graph is only going to get higher. And if you put 100 in, 100 plus 5 is 105 squared. That's only going to come out as a big number. So the graph will go up to infinity on the left-hand side and on the right-hand side. So when x is minus 5, that's the minimum value we can get out. Okay, where did the minus 3 came from? Because if x is worth 0, we'd get minus 3 there. So that's where it cuts the y-axis at minus 3. Y is minus 5 on the graph. As I said, when x is minus 5 plus 5 is 0. 0 squared is the lowest number you can get from squaring. Minus 28 when it cuts there. So this point here is actually at minus 5, minus 28. Now I say we don't really seem to need this, but we don't need this for additional maths. We won't find any past paper questions with it, but it's nice to show you the idea where this comes into the type of questions you're going to be asked. For additional maths, when completing the square, quadratic equations will be in the format where A is 1. Okay, when you do A-level maths next year, A will not be 1. A can actually be a whole, well, it'll be a whole number, but it can also be a minus. I've seen a couple where they start with minus 1x squared or even a minus 2x squared, but that's for worrying about in year 12. Additional maths, it just starts with 1x squared. When you factorize expressions, then they will start with 15x squared and things like that. But for completing the squared method, you just start with A is 1. Okay, before we look at the past paper questions, I've just written 6 questions for you here to think of and practice yourself. So that's question 1. And I'll stop video if I was you, go through it. I put all the 6 questions on before I put all the solutions on. So I leave all the 6 questions here for you. I've deliberately made some of a mixture of minuses and pluses, and you might find there's something slightly different on 5 and 6. So as I say, you've got 6 questions. If I was you, I'd stop this tape for about 10 minutes, but I'll be carried on soon. Now, obviously, you'll notice question 1 and 2 are very similar. It's trying to get you to see the difference with the minus and the plus sign. Now, in a minute's time, I'm going to put the answer up to number 1 and number 2 so you can see what's going on. Obviously, you can reverse this recording to go and see the questions, or alternatively, take a photo of them on your phone. But I'll be dragging on to the next slide. Okay. The answer's in this form. So there's the answer to number 1. Half of 6 is 3. 3 squared is 9. But I've got to take away the 9. Sorry. So minus 9, subtract another 103, goes to minus 112. And the second one, almost the same answer. It's still minus 112 on the end, because if I do minus 3 squared, it's worth 9. So I have to take away the 9 to counteract it. So take away 9, take away 103, well, gives you minus 112. So negative 9, subtract 103, gives you minus 112. There's the third answer. Where did I get that from? half of 14 is 7. Half of negative 14 is negative 7. Negative 7 squared is 49. So I take away 49 to counteract it, but take away negative 49 plus 1 is negative 48. Again, I think I want to check my answer here. I think there might be a mistake. Now, regularly when I'm in school, I teach by mistake. So I'm going to stop there and see if you can work out where the mistake is. Okay, half of negative 2 is negative 1. Negative 1 squared is 1. So I need to take away 1. But 14 take away 1 is not minus 13. 14 take away 1 is positive 13. And I would regularly teach by mistake to get people to see what's going on. So hopefully you saw that one. That is a mistake. Would have cost me a mark, certainly. That should have said plus 13. Because 14 is in the original question. Take away the counteracting 1 is plus 13, not minus 13. Now 5 and 6 are slightly different. This be reason. Half of 5 is 2.5. Now I don't think I've seen one of these on additional maths paper yet. I've seen them on an A level. But I don't think I've seen it on additional maths, and you'll see because I've got all the questions coming up in a minute. But half of 5 is 2.5. You can use a calculator now, but the square of 2.5 is 6.25. So I take away 6.25 and take away another 3 to give us minus 9.25. Okay, you can use 2.5 squared on your calculator. I'll let you think about number 6 because it's very simple before beaming my answer up. Okay, so here's question 6. Half of minus 3 is minus 1.5. 1.5 squared, so you use your calculator, but 15 squared is 225, so 1.5 squared is 2.25. So I have to minus 2.25, add the 7, makes it plus 4.75 on the end. So that's basically giving you half a dozen examples of showing how to get them in their form. Now, if you can get them in this form, you're generally going to score 2 marks. There's a little bit added on when we get some past paper questions. So here's some past paper questions. Use the method of completing the square to find the least value. Now, what I think would be worthwhile you doing is just complete the square first of all, and then I'll explain about the least value. It was on slide number 2. So I'm just giving you a couple of minutes to get your head around completing the square. It's worth 3 marks. Just so you see how it's worded on exam. If you're wondering where part A was, part A might have been a factor theorem question, might have been a different question. On this paper, part A was actually a factorize. Okay. So first of all, I've completed the square by doing x plus 5. Half of 10 is 5 plus 5. Square it is 25. So I take away 25, add the 15, and the 15 is on the end there. Then I've simplified it like I've said so far today. Minus 25 plus 15 is minus 10. Now, the least value this graph can ever possibly get to is at minus 10. I've circled that in purple. I've circled the minus 10 there in purple just to show you where they came from. Now, this question doesn't say when does it occur or for what value of x is it the least value. But it would occur when x is worth minus 5, would give us the least value. There'll be another slide coming up with showing that in a bit. Okay, so the top line is what we've been doing for the last half a dozen questions. The least value is the minus 10 bit on the end. Here's the questions, very similar. Looks as though it's almost been cut and paste. The wording is exactly the same. So that's why I use past paper questions, just to show you how it looks on exam. Off you go. Go and see if you can have a try. That one's very similar to the one up above. Okay, so let's run through this. So half of 12 is 6. X plus 6 all squared. Then it's 6 squared is 36. Take away the 36 plus 5. So I've shown you where I got the minus 31 from. And the least value equals minus 31. Pretty straightforward. You get a mark for writing the complete and square bit. So if you do x plus 6 squared, you get a mark for that. And you get a mark for the minus 31. And then I'm writing the least value as minus 31. As I said, I've seen people have missed off the squared. So they lose both the marks here. So just be aware of that. It's called complete and square, and that's why it's called complete and square, because it's got a squared on it. Now, I've started with all the straightforward past paper questions, which just say use a method to complete the square to find the least value. So again, very straightforward. All these three have all had pluses in them as well, which is sort of interesting. I'll give you a minute or two to work on that one. Okay. So fairly straightforward. Half of 10 is 5. Remember, always, when I often teach, I will set up by drawing the brackets, putting the squared on the outside for the problems I've said people have had before, straight away putting the plus in the middle, and then I straight away put minus, and then I leave a gap, and then I put +3 on the end. That's certainly how I start when I teach it in my school, just to set up the scene so they know how it looks every time. Okay, minus 25 plus 3 is minus 22, so the least value is minus 22. That's 3 marks. Now, in the additional maths papers, 2.5 hours is quite a long time. In fact, I think it's probably a bit too long, but it's a long time to do, so you have so much time. So just make sure you read the question, don't make any daft mistakes, like putting, for instance, minus 28 here or putting plus 22 like I did earlier. 3 marks, you sort of allocated about 5 minutes. That question won't take you 5 minutes. Next one now. This adds a little bit more this time. Okay, so I'll let you have a read, see if you can spot what's different. Find the value of x when it has its minimum value. So by completing the square, find the value of x when x squared plus 14 has its minimum value. You must show you're working. And there are calculators that will do it all for you. That's why it will regularly say on exam questions, you must show you're working. So see what you can do. There is, I have mentioned this on slide 3, but I'll go through this in a minute and then it will help you with the next. Okay, so first of all, we're going to have x plus 7 all squared. X plus 7 all squared minus 49 plus 9, which gives you x plus 7 squared minus 40. Now, again, when I use this in my own school, first of all, I write the maximum occurs and I try and like them to see what mistakes I've made. So they've told me I've written maximum. Well, as I say, this is a positive quadratic curve, so it would be in a U-shaped smile, so it won't have a maximum. If you look back at the original picture, the first graph I drew on this presentation, it was a positive x squared, so it only had a minimum. So the minimum occurs when x plus 7 equals 0. Where do I get that from? Because 0 It's the lowest answer you can have when you square it. Any other number, if you said minus 100, because when you square minus 100 becomes a positive answer, so it gets biggest, gets bigger. So where did I get this from? X plus 7 equals 0. Take away 7 from both sides, so x equals minus 7. That's when it is. Find the value of x. That's the value of x. Write down the minimum value, well, that's what we've done on our last questions. And the minimum value will be minus 40. Where's that come from? From the minus 40 there. Now, the next couple of questions are linked to this style. So that's why I'm just going to run through this again. Completing the square, fine. Hopefully you're used to that by now. Pretty straightforward. This one actually does say it's a minimum value, so it's even more easy for my pupils to work out whether I've written the wrong thing. Would I be penalised? I'm not sure. I probably should have done because it's bad maths, but I might have got away with it because I've said so x equals minus 7. Right. Next one. And this one is, as it says here, is a little bit different. But it's linked to the last slide. So I'll give you time to work on that. Okay. So first of all, usual routine now. Half of 12 is 6. But 6 squared gives us an extra 36. So I'm minus the 36 to counteract it. X plus 6 all squared plus 13. Got 2 marks for that. The least value is 13. Where do I get the 13 from? From the 13 here. Why is that the least? Because the lowest number you can ever get to square is 0. 0 squared is 0. That's the lowest number you can get from squaring any number. And there's something called imaginary numbers in further maths at A level. But for real numbers, that's the least you can get squared. What is the value of x when it has its least value? So this is written slightly different to the last slide, but it's the same thing. So the answer is for there, x plus 6 squared, it's got to equal 0. X plus 6 has got to equal 0. So x equals minus 6. Now I have shown a bit of working when I got that from, but as long as I've written down x equals minus 6, I'd get the mark. A lot of people just learn it's the opposite side. That's bad maths. But if it reinforces your belief where this comes from, that's why I put my working in. So next slide. Okay, now this seems to be how the questions have been written in the last, I don't know, 5-6 years. Obviously, we missed a couple of years, but they seem to be more in this format where they give you answer boxes to fill in. Now, I've been guilty of doing in the last 2 or 3 papers, I've gotten the wrong way around. As I say, additional maths time is not an issue at all. So please make sure you do these the right way around. The minimum value occurs when x equals and the minimum value is. Now, I don't think I've done on this one, but I know I have done in the past where I put these wrong way around and I lost 2 marks. Okay, I'll leave you to work on that one yourself. Make sure you do the minimum value when it occurs, when x equals. Don't put them the wrong way around. So there's the completing the square part. Half of 22 is 11, 11 squared, 121. So take away 121 and that'll leave us with plus 2. Now I've definitely written in here 2 before, and I've written here, well, I could write 11 in, which is definitely wrong. So I'm just highlighting how easy it is to make this mistake. Okay, now I have done my answers correct. The minimum value is 2, where that come from there. When does it occur? When x equals minus 11, and I've shown my working when it does. Now, it's an easy trap door to fall in, because the easiest thing is to say, oh, it's at least when it's 2. You see the minimum value, and you put 2 there. So it's just something to be aware of. Trust me, that's me speaking from past experience. Next question. Now it's lined up the same. So it's in the same format as the previous one, where it says at the bottom, the minimum value is when x equals and the minimum value is. So we'll see if you can work your way through that question. So the complete and square part will be appearing now. Should all be used to this by now. Half of 18 is 9. Again, as I said, I haven't seen anywhere there's not whole numbers in the additional maths course. I mean, so there won't be. Half of 18 is 9. 9 squared is 81, so you minus 81 to counteract. So the minimum value of it occurs when x equals is not 11. X plus 9 squared gives us that. That's why it's minus 9. The 11 comes from 11 there. Now, in some ways, you could say it's probably better the way it's written down here, because you work on the bracket first, and then you work on the constant second. So maybe that's why the question's written in that format. Okay, so another question written slightly different layout, but it's the same thing. So again, I'll give you a little chance to get into that before going through any of this answer. Okay, so there's the answer to the complete and square bit. Pretty straightforward for 2 marks. Hence, find the least value. 10. Now I'm showing you here, I wrote 10 there. The answer box, the answer line takes precedence over anything else. So say if I'd written 10 there and written 35 there, I would have lost a mark. If I'd written 10 there, not filled anything in there, I would have still have got the mark. But when they give you an answer box, fill it in with your correct answer. When does it have its least value? So as I said, it's the same question as we've just been doing, but it's writing in a slightly different order. So for dot E3, I've got to go back up to dot E1 to help me. Okay. I'm sure you'll all be aware that GCSE questions are all often the same topic, but they're worded slightly different. It's the same in additional maths. And that is the end of the slides to do with completing the square. Hoping you've enjoyed it. You found it quite useful. It is quite samey and fairly quick to work through. And my next presentation will be on factorizing.